So for this video, we're going to go over some ideas about what an octet is and what a valence electron is. So octet meaning 8, right? And from last chapter, we learned about valence electrons. They're the electrons that are in the outermost layer. So for octets, that means that you have 8 valence electrons. Now, if we recall, anything here in the middle, these are not valence electrons in the D block, right? So to count valence electrons, you simply count 1, 2, 3, 4, 5, 6, 7, 8. So you simply count what group they're in, ignoring the D block. That's how many valence electrons something will have. So things that have an octet, the only things that have an octet right out the box, right, are the noble gases. However, helium, how many valence electrons does helium have? Helium has a 1s2 configuration. So helium has only 2 valence electrons. So not everything's going to abide by the octet rule, and it is a little pet peeve of mine that it's not technically a rule, is it? If not everything abides by it. So we look here, and technically neon has an octet because it has 2s2, 2p6, that's 8 electrons. So from neon down, these guys have an octet, right? So if you guys go back and recall, what charges do the 7A column tend to have, right? So F tends to make an F minus, right? So why is that? Because if F gains 1 electron, it will have an octet. So F minus has an octet. Cl minus has an octet because it gained 1 electron. Cl, by its right out the box, neutral Cl, how many electrons does it have? 1, 2, 3, 4, 5, 6, 7. So it just needs to gain 1 more to have 8. So then we also come over here and let's see how we memorize these, how these actually also tie up into the octet rule. Potassium, for instance, anything in the column 1A, what charge does it normally have? 1 plus, right? So if potassium lost its electron, its 1 valence electron, it would have the configuration of argon. So it would have 8 electrons, right? Because remember, it has 3s2, 3p6, 4s1. If we got rid of that pesky 4s1, the third energy level would now be the valence, right? So let's talk about a couple things that are from the homework. It says phosphorus, number 4 from the homework. Phosphorus likely forms what ion? So let's find phosphorus, right? Now, phosphorus would like to have 8 electrons. So is it easier to gain 1, 2, 3, gain 3? Or to lose 1, 2, 3, 4, or to lose 4 electrons? So no, it's easier to gain 3. So you'll find that this column likely will gain 3, just like nitrogen. Remember, we remembered nitride gains 3 electrons. So phosphorus is likely to form a P3 minus. And I did notice that they do ask questions about the electron configuration of ions. I did a video on that, so make sure that you check it out. It's under a chapter 7 label, so make sure to give that a look. Then this is similar to one of the questions that I have on the quiz. How many valence electrons are in this compound? So a big thing about being able to draw Lewis structures is being able to count valence electrons. You'll find that that's our first step. So let's look at how many valence electrons are in aluminum. Right, he's right here. So 1, 2, 3. So it's 3 plus, and then I'm going to say 3 times however many Cl has. How many does Cl have? He's in the 7th column, right? If we ignore the D block, 1, 2, 3, 4, 5, 6, 7. So 3 times 7. So 3 plus 21, we have 24 valence electrons. So it's very similar to one of the questions that's in the quiz that I'm going to open up in a moment. So I hope that this helped out a little bit, and good luck to all of you.